In this video, we'll talk about designing and securing APIs for the AI applications. Connecting AI with user-friendly applications requires a reliable bridge, the application programming interface, or the APIs. A well-designed API not only links the users with AI, but it also ensures data security and support for future improvements. APIs act as intermediaries. So the input is sent via the user interface, which is sent to the AI model, and the response is sent back in a format that the application can use. And this process it requires speed, accuracy, and security. For example, the user requests a story. This request is sent to the AI model, and the response is written back in a format that the application can use. In this slide outlines the security for the APIs. So it's important to have a robust authentication and authorization in place. We Using the authentication, it identifies the client, and then comes the authorization. And the encryption is non using the TLS is non-negotiable. So this slide highlights the OAuth authentication, which is a gold standard for user delegated access, and it uses the temporary tokens. And we also have the API keys and the manage identities, which are best for the cloud service to service communication. And authorization, it defines the permissions based on the roles. Building a resilient API is crucial, and we need to ensure clear error handling. We need to ensure that the error object is using the JSON format, and it is using the standard HTTPS codes with a human readable message about the error. And it also defines the missing uh, field. For example, it is also giving the information about the missing field or the error description. uh, the standard HTTP status codes are universal for developers. As you can see, the 200s status codes, they imply that the request was successful, and the 400s status codes, it denotes that there has been a client error, and we need to check the code and fix it. And 500s codes, they imply the server errors. To build a resilient application, the API clients, they should implement the retry logic. So when a request fails, instead of retrying immediately, we have to wait progressively longer, and this uses the exponential backoff with the jitter method. So that we wait progressively and before retrying, and we avoid crashing the server. And for operations that modify the data, it's crucial that we use the idempotency keys, which ensures that if a request is sent twice, or there's a duplicate request where there has been a timeout in the middle, this action happens only once. So these are the two techniques that we need to follow for server related issues or the network glitches. This slide outlines the scalability and the future proofing. and